Hello guys, another problem, 3D particle equilibrium with forces. So this is an easy problem, and I know I always say easy problem, but this is really easy problem. It says here determine the magnitudes of F1, F2, and F3 for equilibrium. So this, and that, meaning we have three unknowns, and we have three equations: summation of forces in X equals 0, summation of forces in Y equals 0, summation of forces in Z equals 0, or we can say summation of forces as vectors equals 0. It's the same thing. However, we have 1, 2, 3, 4, 5 forces. What is the objective? Convert forces or resolve forces in or get the components of the forces in Cartesian, meaning ijk, in other words. It's in equilibrium, so it has to be 0. So add all in I, all in j, and all in k. And 3, solve the system. Because you're going to come at the end with a system of 3 equations and 3 unknowns, no matter what you do. So let's start the problem. For F1, F1 has these weird angles here, which are not weird at all. Those are alpha, beta, and gamma. You know, alpha, what is alpha? Alpha is the angle that is forming with the x-axis, which it should be here, by the way. It's part of the problem. It's just not given. So cosine alpha I, cosine beta j, and cosine gamma k. The first force F1 as a vector will be the magnitude of F1 multiplied by cosine 60 in the I direction, cosine 60 in the j direction, and cosine 135 in the k direction. For F2, beautiful. F2 goes entirely into the z-axis. So F2 as a vector, Cartesian, will be 0, 0, and F2 in the k direction. That's it. F3, beautiful as well. F3 goes in what direction? Negative j. Why negative? Because it goes to the opposite of the positive, and we don't know the magnitude, so that's going to be 0, negative F3 as a magnitude j, and 0 here as well. And for what other forces? We have this force here. I don't know how much is this force here, but I know it goes in the negative. I mean, I know how much is it. It doesn't have a name. That force goes into, I don't know if I put a name to that force, but anyway, unknown force 1 or unnamed force 1 is negative 225 in the I direction. So it's negative 225 here, I, and 0, 0. And then you have this other direction, this other force of 150, which we have to decompose in components. And these are projection angles. So the first thing, the easiest one, is calculating this one, this component, because this angle is 45 degrees. And basically that's what we have to do. We have to get 150 sine 45 degree. That will be this one, 150 sine 45 degree in the k direction. Now for these x and y, first we have to drop this 150 in this plane, which will be 150 cosine 45. Let's put that 150 cosine 45 and 150 cosine 45. But then this line I have to project it to the axis. So if I'm going to project it to the x-axis, which is this one, this line cosine 30 will be in that axis. And this line, which is the same line that we calculated now, sine this one, but remember the direction is this and that. So it will be that line multiplied by sine 30 going to the negative direction. So it will be negative and it will be sine 30 here. And this is I and this is J and this is K. This is the same force. I'm sorry about that, but I didn't calculate the total. And now what do we have to do? Establish our equilibrium. We are going to add those forces all together. And then you will have the first equation will be F1 cosine 60 plus 150 cosine 45 degree cosine 30 degrees minus 225 equals 0. And from here I can immediately calculate F1. So let's do that. It will be passing to the other side 225 positive minus because when I pass this to the other side it's going to be negative 150 cosine 45 cosine 30, and then I'm going to divide it by cosine 60. It's solving for F1, that's it. And F1 will be 266.29 pounds. Done. The second one will be, now everything in J has to be 0 at the end. When we add these, that's what I'm saying, when we add this in equilibrium, this has to be 0, this has to be 0, and this has to be 0. The first one is this. The second one will be this one, F1 cosine 60 minus F3 minus 150 cosine 45 sine 30 in this part, and that would be it, right? I don't think I'm missing anything. No, I'm not missing anything. I have F3, and then I have 150, and then I have F1, but F1 is this value here, equals 0. So if I solve for F3, what I'm going to do is I'm going to pass F3 to that side, and everything else will end here. So F1 is still in the calculator, the value, F1 cosine 60. Let me go to answer first, times cosine 60 minus 150 cosine 45 sine 30 degrees, and that will be 80.11 pounds. F3, and for F2 we go to the last column, F1 cosine 135 plus F2 plus 150 sine 45 equals 0, and F1 is known. This is the value for F1. So I'm going to pass these two to the other side, and that will give me the value for F2. So F2 will be, let me solve it here and then I'll pass it to the other side. F1 266.29 cosine 135 plus 150 sine 45. That's negative 82, but I have to pass it to the other side, so it will be 82.23 pounds. And that's the problem. That's it. It's really easy. If you don't want to convert it in Cartesian, it's okay. Then you just look at the equation directly. And you can say, okay, what is going in the x direction? In the x direction is going this component for F1. What is that component? F1 cosine 60. That's it. What is going in this force in the x direction? It's negative 225. There you go. It's there. And what part of this force is coming in the x direction. It's just cosine 45 sine cosine 30, cosine 45, cosine 30, cosine 45, cosine 30. You can do it either all of them at once, or you can do it one by one in that way, and you get the same result. Thank you for watching, guys. See you in the next video.